Hello, my name is Alvaro and I'm a quantum computing educator at Xanadu. Today I will be showing you how to install PennyLane on your personal computer. I'm going to be using a Mac, however these steps work for any operating system. There are some minor differences in Windows and Linux, but I will make sure to point them out as we go. The first thing that we need to learn is how to open a terminal. In the case of a Mac, the way we do this is by clicking on the Spotlight Search button, then writing Terminal, and pressing Enter. This will open the terminal, which looks like this. In the case of Windows, you can just search for CMD, and in the case of Linux, you can use the shortcut Ctrl-Alt-T to open the terminals. They will look a bit different from the Mac version. PennyLane is a Python library, and it needs a version of Python of 3.7 or above in order for it to work. So how do we verify that we have an updated version of Python? One way is to go to the terminal and write Python --version, press enter, and this will tell us the version of Python that is installed on our computer. In our case, we have 2.7.18, which is really outdated, so we need an upgrade. One way to make sure that you have an updated Python version is by using the Anaconda installation. Anaconda comes with several machine learning packages that are going to be useful for us down the road when we do some quantum machine learning. Make sure to check the link down below to download Anaconda for your preferred operating system. The installation procedure is a little bit different on Windows, Mac, and Linux, so make sure to follow the appropriate instructions. Now that we have Anaconda installed, we can verify again that we have the correct version of Python in our computer. So we write again Python --version, press enter, and now we have 3.9.12, which is greater than 3.7, so we're good to go. So how do we install PennyLane now? Well, we just write the command pip install PennyLane. Press enter, and then you should see some installation messages. In our case, we already have it installed, so it says requirements already satisfied, but you would see something else. Now that we have installed PennyLane, we would like to start coding. We need a development environment, and in our case, we are going to use Jupyter Notebook. Jupyter Notebook is useful because it allows you to run small chunks of code and verify the outputs. So how do we run Jupyter Notebook? We basically just have to write Jupyter with a Y, notebook on our terminal and press enter. After a few seconds, this command will open Jupyter. To create a new notebook where we can code in Python, let's just click on New, Python 3, and this will open a notebook which contains elements like these, which are called cells. For example, we could use the first cell to define a Python function. Let's define sum of A and B, and this function will just return the sum of A and B. So let's simply return A plus B. Press Shift Enter, and that reads your function. If I would like to use this function, I would simply write on another cell sum 3 and 2, press Shift and Enter, and that will give me the output of the function that I defined before. So now let us use this Jupyter Notebook to check that our installation of PennyLane is working properly. To tell Python that we want to use PennyLane, we should write on this cell import PennyLane and give it a short name as QML, press Shift Enter, and that imports the PennyLane library. Now let's write a small script to check that everything is working properly. So let's define a quantum device, and the way you do this is you write dev is equal to qml.device, and the most common type of device is default qubit. So let's write default.qubit in quotes, and then let's give it a number of wires. Wires is equal to 1. Press Shift Enter, and we've successfully defined our device, no error messages, so this means that PennyLane is working properly. If you want to learn more about how to code your own quantum algorithms with PennyLane, make sure to check out the demos that we'll link down below. If you found this video useful, please do like and subscribe. We will be coming back with more. See you later!